Okay, so in ELK masterclass, Elasticsearch beats Logstash and Kibana to master this all component of Elastic stack. Okay, we have created these modules where our duration is 40 hours. Prerequisites is basic Linux knowledge and some basic modules also we have created. So course objective is to understanding the ELK stack, Elasticsearch, Logstash, Kibana, and Beats. Learn installation, configuration, and practical use of each component for efficient data management and analysis and visualizations. Okay. So we'll, as you know, all that the current version is only getting utilized everywhere in market. So we'll go with the latest version or around latest version only, and we'll not work on a CentOS. We maybe work on a Red Hat or Ubuntu. Okay, because CentOS is getting deprecated, so we'll not use that. And also for this learning we need Linux basic, which I consider everyone has a knowledge of Linux. If anybody doesn't have a knowledge, then we have to go through the Linux and basics of file system architecture, basic command, user and permissions, process management, how networking works, ports, firewall, netstate curl, system monitoring. Okay, how we can monitor Linux system. And then we have a JSON fundamentals. Okay, if like we'll do a feedback feedback kind of thing where we will get to know that all having understanding of JSON syntax and structure. And if somebody is not having, we will, because we have to like we have to take care of everyone, that everyone is comfortable with the basics, so that only with these basics only we will be able to understand the advanced feature of Elasticsearch. Yeah. And then we have a parsing and validation in JSON, and working with JSON in Linux, JSON in Elasticsearch. Okay, how JSON is, because JSON is all over the Elasticsearch getting utilized, highly utilized. All the data present in Elasticsearch is in a JSON document format, and all the query we write to fetch the data from Elasticsearch is also JSON. YAML basics, maybe if you guys all already working, then you know that what is the YAML syntax, which is similar to JSON, but have some different logics to define. Okay, it's also a key value pair, but in a different structure. YAML syntax and indentation rules, writing configuration files for ELK, basics, networking and security concepts, HTTP, HTTPS basics, RESTful APIs, okay, cards, SSL, TLS encryption. So we will understand how SSL, TLS are getting utilized and how it is getting configured in Elasticsearch stack, and role-based access control. How role-based access control is happening in Elasticsearch, and how we are differentiating with between different kind of roles and authentication. And then we have a ELK stack overview. After this basic understanding, we will move to ELK stack course, which is introduction to stack, a stack component. How many of you would like to go through basics also, or like is anybody, or like we can move to directly to ELK only? Please comment.
At least it would be
Could
if we can cover
you
JSON
please
and
start
YAML
with
stuff.
the basics?
Sorry.
Could you please start with the basics?
Yeah,
Um,
sure. Okay, so we'll start with the basics. Okay, yeah, sure. So today we'll understand about what we are going to learn, and what overview kind of thing, and I will give you the overview use cases, and how this is getting utilized in IT industries, and or what is the purpose kind of thing. If somebody has a lots of experience, they already may align with those things, and they may be looking for advanced learning only. So that also we will do. but as we have a everyone contribution here, so we have to go with the basics to advance. Okay, then we have a advantage and disadvantages as well, and prerequisites, which is Elasticsearch installation, Kibana installation, and verify the installation. Okay, how Elasticsearch interact with Kibana, and how these both comply and serve a purpose of showing logs in very like high level of uh, dashboards. So that we'll understand here. Elasticsearch. So we'll go with the Elasticsearch introduction, Elasticsearch fundamentals, Elasticsearch architecture, Elasticsearch REST API, types of API, how many types of API in Elasticsearch have, document API, index API, search API, cluster API. There is so many APIs provided by Elasticsearch. So there is a two-way to communicate with Elasticsearch. One is through Kibana, and another is using third-party tool or a direct from API. Okay, Kibana. We'll go with the Kibana. What is Kibana? Fundamentals, visualization. How we create a different visualization. So we'll see 2 or 4 example of each visualizations. Kibana dashboards, Kibana management, index lifecycle management, alerting, using vouchers. There is a feature of voucher in Elasticsearch, which comes with the gold license or platinum license only. So some of the feature is open source, but some of the feature require a license. Okay, so we'll see how we can do that. Logstash, introduction to Logstash. Logstash is the main component who do a data processing to the Elasticsearch database. So we need to understand it completely, how we have to install Logstash, how we have to configure Logstash, and how we can maintain Logstash in a scalable manner, or how we can make Logstash as a central server which handle all the logs and metrics and send it to Elasticsearch. So we'll go with the input, output, filter, grok, and how the Ruby works. Okay, here. And along with Logstash, I will guide you with the basics Python as well, so that if something is not achievable in the Logstash, so we can utilize Python as well. Okay, if somebody wants to learn advanced Python and uh, Python, utilizing Python for data processing, okay, learning will not very hard. Only basics of Python, if we will learn, then we will be able to create our custom data processing pipeline as well. Okay, because sometime some pipelines we need to create in a such a way that it require lots of data filtering and modeling and kind of thing. So that's the reason we need to use uh, custom plugin as well. Okay, but Logstash has a capability that it provide all the functionality to achieve logs it into the Elasticsearch. Then we have a beats. We have a different beats. We will see 2 or 3 beats installation, which is highly getting used, such as file beat, metric beat, heartbeat. Okay, how those are getting utilized and how we can work with them. Okay, so those things we will work here. So this is the bullet points for that. That we will go with the use case and FileBit installation and configuration, FileBit for shipping logs from client to Elasticsearch, and then we'll consolidate each and everything, Kibana, Elasticsearch, Logstash, beats, and we'll move to logging and monitoring. How in a real time all this component align with each other and send a log to Elasticsearch, and through Kibana how we will be able to do a monitoring and curation of Logstash kind of thing. Okay, and there is a APM also. Will basic understanding of APM also, shardings, grok patterns, dissect patterns. Okay, and different type of filters in Logstash also we will understand. And we'll see installation of Grafana as well, how we'll install Grafana and how we'll connect with Elasticsearch to pull the metrics and visualize over the Grafana. Okay. So as we know that as we are already working in IT industry, so day by day there is a many changes happening in IT industry, that things are changing, and there is a wave of machine learning and artificial intelligence as well in this such scenarios and industries. Okay, we have to be very much capable of adopting new things. So Elasticsearch is one of them. Okay, Elasticsearch is a very less cost solution provided by Elasticsearch community, where we will be able to create a central logging system. Yes. So so in current industry and market, there is lots of use cases where in DevOps and SRE profiles, we require to learn about Elasticsearch, because when we talk about observability monitoring and logging, okay, this is essential tool which which is like in every job opening currently in market is asked that do you know Elasticsearch? And Elasticsearch is not a simple or like a simple tool which will be like uh, which can be written as like do you know Elasticsearch, and we'll say yes, I know Elasticsearch. Is it's a vast term, and it's provide a very high level of architecture of Elasticsearch, and all the configuration management and how logging works. So each and everything go with the very broader picture. So to understand Elasticsearch, so Elasticsearch came into the picture to resolve one problem, which is log monitoring. There is a different tool also flowing in the market, such as Datadog. Okay, Datadog is there, Splunk is there, and Dynatrace is there. So Elasticsearch covers uh, like integration with many of the data sources to pull out metrics, logs, and data from different data sources, and provide a capability to store those data in a like a search database, and then it provide capabilities to search efficiently. So millions of records or a huge amount of data you will be able to search within milliseconds. Okay, that's what advantage of Elasticsearch. So in current industry we cannot wait for like we need real time monitorings, real time data visualization. We cannot wait for 5 minutes or 10 minutes to come the data, because the critical issue or incidents require direct attentions. So where it's require highly efficient search. Okay, so that's why Elasticsearch is in the market, is booming, and currently it is getting utilized, and lots of job is getting created utilizing Elasticsearch. So there is a 3 or 4 area where we can go with the Elasticsearch. Okay, if you know each and everything about Elasticsearch: designing, implementation, management, and development. So if you know this all areas, so you will be able to go with the fields of Elasticsearch with 4 profile. One is observability, another one is development, third one is administration, and fourth one is a security in terms of cyber security. So there is a SIEM feature in Elasticsearch. We will also talk about basics of SIEMs and rules creation and cases and timeline, okay, later. uh, so that will give us security perspective as well, how it is getting utilized in security as well. So this is how this is essential tool which provide this 4 area, and there is a lots of agents and cloud integration we can do with the Elasticsearch. There is a lots of module and integrations available within Elasticsearch. That's what make it comfortable with any environment. Like we can work with the cloud environment, we can work with the own premises things, we can work with the microservices, OpenShift, AWS, and on premises Kubernetes architectures. Okay, each and everything we will be able to work with Elasticsearch. So that's what Elasticsearch is getting utilized. And so why we have cleared that logging and monitoring required in any every industry of which is using IT tools and technologies, and they have a different data sources. Suppose I have 100 of databases, okay, so I cannot go to the each and every database and monitor the disk, memory, CPU, or other monitoring parameters. So where Elasticsearch agents help us to pull out data from those sources and make those data available within the Elasticsearch database, and then we will be able to create advanced dashboards and we will be able to visualize those dashboards. So through all this architecture, we will have a 360 view, like each and every corner of system will be captured within dashboards. Okay, those single screen dashboard also will try to create here, through which how things align with the same dashboard. Okay, like suppose we have a network area, we have a database area, we have an application layer. Okay, how this all layer data we will be able to pull it out and how we will make them available in a single page. So then we will be able to correlate. If my network area is down, so my other application is going to impact. So correlation between them also we will be able to identify utilizing Elasticsearch. There is a machine learning jobs provided by Elasticsearch. Configuring those jobs, we will be able to identify anomaly within logs. If suddenly spike is coming, then that is going to uh, 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 captured. And if there is any down spike is coming, then also we will be able to capture those things. Okay, so those kind of things and uh, high level of detection rules will be there. So that's what Elasticsearch capabilities, and we'll understand more about Elasticsearch only here for today. So why we have cleared that logging and monitoring, that is the why. And in current market, if I am doing a job in Elasticsearch developer only, so I know that there is a high paying jobs is available in markets. If you are open to go in India anywhere, okay, so you will see that there is a lots of job getting created, and in Bangalore, in Hyderabad, in Delhi, and in Pune. Okay, I even not mark my profile as like I'm searching a job, but still I get a call within 3 months of notice period. They say, if you are able to join us, is there any buyout option, or how we can hire you? Because if I am a skilled person, okay, with Elasticsearch, then lots of companies is there, okay, to hire us, and to and we will be able to evolve more and create a highly available and scalable architectures for with Elasticsearch, and we'll grow ourselves and companies as well. So that's what available in market. And if you have any question related to any public domain information related Elasticsearch, that how it is getting done and how things are working, so that also I will be able to share with you, because currently I am working with the MNC company only with the Elasticsearch, which is a very large level of data lake environment we have created and working in that. So that understanding also I can share, that how in a real time those things are working. Okay, so in order to clear by only, so there is a scalability distributed design. So in Elasticsearch, data is not present on only on the single server. It is distributed along with the multiple servers. Okay, so that's why it is distributed, and fault tolerance will not happen because of distribution and scalability of Elasticsearch. And while finding matches, so it's require only milliseconds to search data. And relevance, if we are searching any keywords, so all the relevance data will appear within Elasticsearch. It is highly relevant results. So this is the stack solution which is provided by Elasticsearch. So there is a at low level there is a beats, then Logstash, ingest pipeline, and Elasticsearch, which is heart of the stack. This Elasticsearch is like a core component of Elasticsearch. This is kind of a database where all the data going to reside and persist, okay, based on our configurations and management. And beats is interact is a agent, okay. It is connecting with the files, like it's reading files and processing all those data to the either to the directly to Elasticsearch utilizing ingest pipeline, or it is sending data to Logstash. Okay, when we talk about beats, so beats majorly connect with directly to Elasticsearch or directly to Logstash. So why we connect with directly to Elasticsearch and directly to Logstash is that if we need any parsing and modification, then we go with the ingest pipeline or Logstash that do this modification and then process the data. If data is already in a structure format or kind of thing, so we can utilize minimum code in ingest pipeline and we can log the data in Elasticsearch as well. And once we clear store, search, and analyze with Elasticsearch, then we have a top layer which is Kibana. Kibana is a UI interface. This interface interact with the Elasticsearch and provide us the all the administrative privileges through which we will be able to communicate with Elasticsearch to fetch data, to visualize data, to do administrative operations. Okay, all the operations. It's all depend on the users and roles we have created in Elasticsearch. So this is what architecture, like this is what stack solution look like. And there is a Elastic Cloud and Elastic Enterprise and stand alone managed services is provided by cloud services. Okay, there is OpenSearch as well, like in competition of Elasticsearch, which is similar, which is created on Apache Java only. OpenSearch Apache Java. So we'll do with the overview. So as we have communicated, Elastic is the heart of the Elastic stack. Any production deployment of the Elastic stack should be guided by capacity planning for Elastic, whether you use it for logs, metrics, trace, or search, and whether you run it yourself in our cloud. You need to plan the infrastructure and configuration of Elasticsearch to ensure the health and performance of your deployment. So as we set up any new thing, okay, so we need to do a POC and we need to collect all the requirements, and then we have to do a design and implementation. So while designing, we have to make sure that how much scalable solution we can create, and like the infrastructure should be a very, like what we say, dynamic, which we will be able to scale up in future. So that if currently we have designed Elasticsearch to maintain some amount of logs, but in future if those is increasing, so how we will be able to expand and do things. So that's what comes with the Elasticsearch sizing and capacity planning. So that we'll also see. So as we are experienced guys, so we will be able to understand these basic terms, which is storage, memory, compute, and network. Storage is basically where data persists, memory is where data is buffered, compute is where data is processed, and network where data is transferred. So we'll see how these four component relevant with the Elasticsearch. 1 minute. So first we'll see storage, where data is persist. So it's kind of word in a book. Any book where word is we are able to see that particular word. So that's kind of a storage system. Like it is going to be physically available over there. So storage media. What type of storage media we can attached to Elasticsearch. Solid state drives, which is part of the part of the resource management or the infrastructure, okay, offer best performance. SSD is solid state drive, which is competitor of hard drive. Hard drive is like uh, it is built on some chip level of architecture, but it is a spanning disk kind of architecture. So it's read write data on the disk, and it's read write the data on the chip. Okay, so this is very fast. Okay, in current industries everyone is using SSD storage, and some recommendation is also there from Elasticsearch that we can go with the direct attached storage, which is comes with the VMs or your EC2 instance or your physical servers, okay, which is directly attached, and storage area network, and hyper coveraged. Recommendation from Elasticsearch is to minimum 3 GB per second to 250 MB per second read write speed. Okay, so storage area network we cannot utilize. Why? Because if we will use in our infrastructure or Linux system or Windows system the storage area network, this will provide a latency, because we are connecting something which is available in network, not directly. So here we utilize direct attached storage, or we cannot use storage area network or network attached storage. We can we should use direct attached storage, which is like directly a file system which is available within VMs or your EC2 instance. This is kind of some this diagram also I will share with you, so you will have a more understanding on the recommendations that before configuring Elasticsearch, what all are recommendation we have to follow. So if suppose tomorrow we are going with the Elasticsearch installation planning call, okay, in your company, so there is a POC and requirement gathering happening. So you can you can put some points that this is the recommendation, this is the best practice from Elasticsearch is providing. So this is how we should use, and this is the recommendation minimum. So this we have to match. So your infrastructure team, because they don't know what is our need. Okay, in some cases some people use storage area network, some people use directed attached storage. So we have to see and use the best practice. Memory resource. So Elasticsearch built on a Java and JVM heap. Okay, so there is a JVM heap which is like a process and do all the processing kind of thing in a memory only. Okay, it stores metadata about the cluster, index, shards, segments, and field data. This should be 50% of available RAM and up to maximum of 30 GB. We cannot maximize maximize heap size, JVM heap size, while installing Elasticsearch with maximum of 30 GB. Apart from that, because this is recommendation, apart from that it will configure maximum of 30 GB. So this is interview question as well, that how much maximum RAM we should utilize for to configure in a JVM while configuring Elasticsearch. So 50% of available RAM. If your RAM is 16 GB, so 8 GB of your available RAM, and maximum 30 GB only. If your RAM is 64 GB, so at least you can configure 30 GB RAM to avoid garbage collection. You cannot say I will do a 32 GB because that is a 50% of my available RAM. No, because there is a recommendation about maximum memory as well to avoid garbage collection. Otherwise, the logs and metrics and the things will go mess. OS case, Elasticsearch will use the reminder of available memory to cache data, improving performance dramatically by avoiding disk reads during full text search, aggregation on doc value and shorts. Okay, when we do a aggregation search, and once we'll configure a DSL query while pulling out the data from Elasticsearch. So this is in background getting utilized by Elasticsearch, which do a caching of data, which will give us the optimized solution through which it is not going to again and again read write the data from the disk, and it's do a cache as well. And compute, how Elasticsearch uses computes. Elasticsearch process data in many ways that can be computationally expensive. Elasticsearch nodes have thread pool and thread queues that utilize the input output system. Okay, compute resource, the quantity and performance of CPU cores governs the average speed and peak throughput of data operation in Elasticsearch. This is essential to choose uh, good amount of CPU, okay, while installing Elasticsearch, so that because things rely on a core component which is CPU, and there is a network comes in a picture where data is transferred. Okay, so how Elasticsearch uses network? So bandwidth is really a resource. So in net, when we talk about network, so there is a two kind of net things is happen. One is local and another one is outside the network. So local, it means each and everything connected within local network. So things not going like outside the network. And when things go outside the network, that requires some connection, and that will come with the latency and things. Okay, so bandwidth is rarely a resource that constraint Elasticsearch. For very large deployment, the amount of data transfer for ingest, search, or replication between nodes can cause network saturation. In this case, network connectivity can be upgraded to higher speed, or the Elasticsearch deployment can be split into two or more cluster and then search as a single logical unit using cross cluster. So we'll see, we'll talk about and we'll understand about cross cluster search as well when we talk about network. So when network comes in a picture, when we configure cross cluster search. So cross cluster search is kind of two different cluster available in two different networks. Suppose we have a different data centers. Okay, in one data center, we have created one cluster of 100 of servers, and in another data center, we create another 100 server of cluster. And now we want to sync the data between both because it's belong to same company and same resources, and we want to like utilize both the organization to utilize the same like kind of data. So where it's come with the cross cluster configuration, so that both the cluster will share the data with each other and sync. Okay, and it will serve a purpose of that both the different unit of same organization can like visualize and see the data, okay, which is similar. So where this cross cluster search comes, that also we'll see. So terminology and some terms, okay, that what this terms means: cluster, nodes, index, shard, segment, document. Cluster, a group of nodes that works together to operate Elasticsearch, a Java process. So suppose utilizing Elasticsearch service, we created three nodes. Okay, three nodes, and collection of those nodes will say cluster. So three different nodes which is installed on three different separate operating system, and once we align all those three nodes with each other, so that will create a cluster. Okay, and if like we'll understand more and deep about cluster, how that cluster get configured, how scalable cluster we can configure. So those practical ones will do those practicals, we'll have a more understanding that how cluster is get developed and how cluster works. So a group of nodes that work together to operate Elasticsearch as a Java process. Okay, and cluster is kind of like, I will in the next slides I will make you understand how cluster look like with Elasticsearch. And there is a node that runs the Elasticsearch software as a group of shards that perform a logical data. Okay, nodes is a part of cluster, one unit of a cluster. Index is a kind of database schema where we store our data. So in here we say index is a like a data collection entity or object where all the data going to be reside in form of shards. Okay, shards is like collection of shards become an index. Index is a like a data object, and within this index object there can be a multiple shards. And once we'll go deeper with understanding of shards, so you will understand that how the shards are, and shards is a crucial component of Elasticsearch storage. Because if we are doing implementation of shards in correct manner, then only we will be able to create optimized Elasticsearch cluster only. If we are not able to uh, define shard sizing and types, then it can become a complex, and it can lead to a complex issues. So that's also we have to take care. Shards, when we talk about shards, a loosen index that store a process a portion of Elasticsearch index. So what is loosen? Loosen is a Java library. Okay, Loosen is a Java library. So in each programming language there is a library. Okay, library is kind of a bunch of code. Okay, so Loosen is a Java library through which Elasticsearch uses Loosen Java library to write text data to the shards. Okay, which is available within index. So shards are like, this is like a very small terms, but in interviews or in capacity planning or installation of Elasticsearch, it's play a crucial roles. Okay, to understanding of these terms is very important. So Lucene, if somebody asks a question that what is Lucene, so Lucene is a Java library through which Elasticsearch write a text data to a shards. Shards is a like in a file system some kind of partition where data is going to return in a file system. Okay, in a if we are using Linux, so in Linux, in a disk it create a partition or some amount of space where it will write data utilizing this loosen Java library. So that's what shard is, and we'll see how the shards look like, how we'll manage the shards from Kibana or Elasticsearch, and we'll see, because it's play a crucial role. It can even make your whole cluster down as well. Okay, if we have a shard issues. And segments is a loosen segment that immutably stores a portion of loosen index. We cannot modify the segments. Okay, so index is a collection of shards is a collection of segments. Segment is a portion of a loosen index. Okay, which is in a text format. Okay, if suppose we'll say document. Okay, first we'll understand document. So document, a record that is submitted and retrieved from an Elasticsearch index. So suppose in Elasticsearch we I will show one live example here. Okay, we'll set up our live environment as well as soon as possible, or maybe within this weekend only. And I will show you the documents as well. So for example, document will look like this. So in Elasticsearch, document look like this. Okay, where we will be able to see our data in a key value pair. So this is key and this is value, and this is key and this is value. So this is nested JSON. Okay, I talk about JSON architecture. So beginning of the next sessions, So we'll cover all the basics first. Okay, for now just try to understand. Okay, if you are not able to understand nested JSON or JSON what it is, then we'll go with the basics, and next sessions we'll start with basics and will our module architecture. Currently we are understanding what these terms are, and once we'll go next to next, we'll understand each and everything in a deeper context, and we'll see physical appearance of those contexts as well, that what it is, and we'll experience those things, that if we are saying shards, so what is shards, if we are saying document. So I was having some documents, so that's why I am showing you here that what it is. So this is a document, okay, where particular data is there in a text format, and this particular format is a JSON format. This data format is a JSON, and all we say is a text. So it is available in a key value pair, so key and their value. And if you'll see a metric name, so metric names will be there, values will be there, and if we'll say a tags is a field, and in a tags we'll going to have a some value there. Okay, so this is a document, this is a single document. So if somebody asks a question that what is a document, so document, a record that is submitted to and retrieved from Elasticsearch. This is particular a document, this is going to be submitted to the Elasticsearch. We can say it we can say it a event, we can say it a document, we can say is a JSON payload, multiple name we can give it to the same entity. Okay, so don't get confused what is JSON payload, what is document, what is event in Elasticsearch. So these all belongs to same things. Okay, but the context is very different. Once we are working with Elasticsearch, then it is a document. We are working with a Logstash, then it is an event. And if we are working outside Elasticsearch and outside Logstash, then it's a JSON payload. Okay, payload, it means like it's consisting some informations. Okay, so it is a payload, and more names we can give it in a different context. Okay, so don't be confused, these all things are similar, but in a different context it is like different. Yeah, so we understood about document. So this group of document, a single record we see, a group of document is a segment, and segments, group of segments is a shard, and group of shard is an index. Okay, so this is how this particular data is in Elasticsearch going to be available, and the background of data storage we have understood. Is there any question in these terms, cluster, nodes, index, shard, segments, document? Because these terms you have to like in your day-to-day activity you have to like uh, you have like a kind of utilization of these terms. So we will create a similar whatever architecture I have created here. So we'll try to create similar architecture on premises as well as AWS if this course permits, and I will discuss that AWS also we can utilize. So similar architecture will create on both the labs, and we'll try to understand. Okay, so this is the complete architecture of Elastic Stack, where Kibana is a top layer, Beats and Logstash is a bottom layer, which reads data and send a metrics to Elasticsearch, and Elasticsearch cluster. So utilizing same Elasticsearch configuration, only with some different roles and things. Okay, we will be able to differentiate between different entity. Okay, suppose we have a coordinator nodes, we have an ingest node, we have a master node, we have a data node, we have a machine learning nodes. So all this group of nodes serving different purpose. Okay, So coordinator node is working as a load balancer. Ingest node is working as a data parser. Data node is working as a storage media. Master node is working to manage all cluster state, that my all cluster is up and running and what is the metadata and things. Okay, and data node is storing shards and index and data. Okay, it is not doing any any other thing than that. Machine learning nodes doing computation of machine learning jobs. Okay, if we have a machine learning jobs, then those jobs going to run over these machine learning nodes. Okay, it's dedicatedly created for machine learnings. And in data node we have this so in elastic in any architecture, AWS or in your on-prem architecture, you have this directory. Whenever we do a Elasticsearch installation, and once we'll go with the microservices, then we will be able to modify this persistent volume with with like with some other uh, directory as well. But by default from Elasticsearch, this directory is storing all the data. So in every database there is a one directory where it store data in form of some logical object. Okay, so suppose in some cases some databases store in files, some database store in their own extensions and formats. Okay, in Elasticsearch we store in a form of index, shards, segments. Okay, so one in like if we are doing ingest of any data, if we ingested any data, and we created a index template, and where we have specified for now, if any terms you are not able to correlate what is index template, what is shard, what is this. So currently we are understanding this, okay, architecture, and once we'll go with the complete flow, then you will be able to correlate and understand more, and nothing will be away from your hands or eyes, that what it is. I don't know from the perspective of Elasticsearch. Elasticsearch is very broader like kind of is tech, and it is evolving day by day as well. So we'll understand the common areas which is required to which is required to have understanding at level of engineer, that what all things we need to understand. Okay, and logical thinkings to build upon that. So this is the directory, and once we create an index, so we create a shards. Okay, shards can be primary shards and replica shards. So if you are able to see here, we created one index. Okay, and one index have a one primary shards and another is a replica shards. So primary and replica shards, okay, will see it practically, but for now try to understand it is a backup of this particular data. So suppose if this particular shards got corrupted or got lost or something happened to these shards, so our data will not lose, our data will be there in replica shards. Okay, and if we are not able to recover the shards, so this replica will become a primary and another replica will be created, and this shards is going to persist on particular this data node. Okay, so replica shards going to persist on different data node. So suppose my this data node go down, it is not available within cluster, so I will be able to read data from here. My cluster will be read data from different backup data. So that's why in a background, like if some nodes are down, okay, if one node is down, so we will be able to at the same time, if both the nodes down, then only we have a issue. If one node go down and another is available, so we have a backup of data, which is why I said distributed platform. So data is getting distributed among different data nodes. And again, replica is also consist of segments, and primary is also consist of segments, and segment consist of documents. Okay, so this is how this look like architecture. So is there any questions in next? I will we'll go with the module by module. From next lecture we'll understand, try to understand each and every aspects, basics aspects, and then we'll go with the broader aspects. So in next session we'll cover all the basics only.
So we have the questions, but these shared indexes and
Right,
data
right.
analysis is not. So we are not sure about exactly what you are telling. But
Yes, yes, yes. So I show you a high level of diagram. So
okay,
when we'll start, okay, what we are going to do, we are going to add more modules, as you guys mentioned, AWS and vouchers and some webhook URLs and some database monitoring. Okay, we will add those topics, but first we'll go module by module. So first we'll go with the fundamentals, Linux basics, JSON fundamentals, YML basics, basics networking and security concepts, and then we'll go with the ELK. Okay, and we'll understand. So this session is just to introduce myself to you, and to get your background, and just to understand what is Elasticsearch and how architecture look like, and what is the use case. Okay, use case we have clear out that for logging and monitoring, this is highly getting utilized, is cost saving and efficient and highly scalable. That's why each and every big companies are using it. So it will see Elastic search. So we'll see many companies: Amazon, Wikipedia, GitHub, Cement, Uber, Netflix, Cisco, VMW, and Adobe, and this kind of majorly known companies, as well as in market there is a like 100 or 500 companies there who is utilizing Elasticsearch, and this field is evolving. There is a less engineers available in market of Elasticsearch. That's why competition is very less. Okay, if you have a some level of knowledge and not uh, very high level of knowledge, then only also you will be capable of gaining those jobs as well. Like that's what my understanding is, and my personal experience said that this is evolving, because I see some of the companies migrating from Splunk to Elasticsearch and Datadog to Elasticsearch. I'm working in one of the project where we are migrating this Datadog to OpenSearch. Okay, so why? Because it is costing them very high. Okay, and it is, and the same purpose can be searched in Elasticsearch in a very cost saving and kind of cost saving and as well as efficient way. So why they use these highly paid softwares? Okay, so peoples are migrating their applications from Datadog or from to Prometheus, Grafana, TickStack, and OpenSearch and Elasticsearch. Here things are migrating from different. So I majorly migrated data from Splunk and Datadog. Okay, which is very highly used platform in current industry. They have a like a different use cases, but Elasticsearch supports various kind of features. Okay, that's why it is highly getting used. So this is what overview session about Elasticsearch and understanding of basic terms and whole architecture. And once we'll go with the next sessions, we'll go with the basics. So if there's any question and anything to discuss, we can discuss. Otherwise we'll meet in a next session and we'll start from module 0, and then we'll go day by day. We'll see ourselves growing, and we'll add more modules as well if that is not available. And if you guys see anything more need to be understand, that also will add here, because all the basics and advanced things will add here in this session, in this course. So if there is no question, then we can drop off for today, and we can meet in the next session.